Hi, today we're looking at some VBA macros that I wrote to help me doing Tensor Calculus. In Tensor Calculus, you get these horrible things like a Riemann tensor, which expands into this chappy here. Covariant derivatives occur all over the place, and there's a covariant derivative, and that expands into that sort of thing. The covariant derivative operates on another tensor. And you get Christoffel symbols, which expand into this sort of thing, which are related to the inverse metric and the metric. G and the upper indices and G with lower indices being inverse and ordinary metric respectively. And as you can see, the covariant derivative expands into bits which have Christoffel symbols in it, as does the Riemann tensor, and even the last two terms have two Christoffel symbols which are contracted together. This lambda here is what we call a dummy variable, and that means you're summing over those, summing over lambda. And in each of these you have a dummy indices being introduced. So I've created an interesting little tensor equation here. I've got two copies of it so we can see what it was before and after. And if I go now, I go and hit that expand equation button, we'll see something happening. It all looks a bit faint at the moment, but there we have it. So we got the Riemann tensor got expanded into those four terms there, and the covariant derivative into those three terms there. Three terms because it was a rank 2 tensor you were taking a covariant derivative of. With a bigger rank tensor, you get there's more terms. And then, of course, you need to go and expand the Christoffel symbols in there, which all gets a bit glassy. Okay, so we'll copy that equation down here, it's like that. And now I'm going to use the this thing which inserts a new equation with a number on it. It picks up the number from the one above. Obviously we've got a slight problem here because we've got two equations, number 9. I would then use the renumber equations to actually sort that out. Right, so we copy this equation down, and now each of those Christoffel symbols is going to turn into more symbols. How many more? Three more components. So it's going to get quite big, this thing. There we go. And you can see it all coming out sort of slowly. It's more interesting. Word is telling me it's not responding at the moment. That could be a slight improvement in the macros. So it doesn't seem to do that. Here we go. And nearly finished. It's got on some fairly exotic dummy variables there. Zeta, obviously, in there as a dummy variable. Right. Theta is a dummy variable, not very good, really. Have theta as a dummy index, but there you go. Okay, so there we are. Now we got this very unpleasant expression which you wouldn't want to see at all. Now, there's another thing you can do with these chaps is that you can write out every component if you know what the coordinates are and what the metric and the inverse metric are. That's a very painful process because there might be, well, with 4 dimensions, you could have each of those indices can take one of 4 values. So you might think you get 64 components. Well, you're lucky. In fact, due to symmetry of the lower 2 components, you only get 40. And right, so now looking at this near-Earth metric, which I had to sort of use in exercise 3.06, the coordinates are time, distance out, 2 angles like longitude and latitude. So I pick up those coordinates, it shows me what I've got there, and this is the metric which we were given, and pick up the metric, and it cleverly works out that it's a 4x4 metric, and then we have the inverse metric, which is very easy to work out in this case because the metric is diagonal. And it's now loaded up the 4x4 metric. Now, the 4x4 inverse metric. And now, what I'm going to try and do is calculate all the Christoffel symbols. Here we go. I hope you see something. Where are we? Right gammas. There's the Christoffel symbols. Here we go. That's the first one. Well, as I told you, there were 64 of these. It's going to work out. Some of them are the same. Okay, there's all the T ones. So that's the time coordinates done. Now we're coming to the R ones, which is the R coordinate. And I could pause the display. Okay, now we're doing the phi coordinates near the end. 5, 5, 5, 5 is the last one. No, it's not quite the last one. Yes, it is. And there we are. We've finished. Woohoo! And we have added. We should have added. Well, let's say 64 equations. The last one is 74, and the first one is 11. That sounds like about 64 equations. As you can see, some of them are the same as each other. And here's one, for example. And so what it's done is it's calculated them. It's calculated all the zeros correctly. Doesn't do differentiation, and you know, that's pretty straightforward to do though. So it saves you a lot of time and trouble. And it got the answer right, so I had to calculate these in the exercise, and I checked. Okay, thanks very much.